We're looking at the back page of Trig quiz review number 3, or Trig quiz review 3. Let's look at number 4 here. It says, given the function y equals x minus 2 cosine of x on the interval, on the closed interval from negative pi to pi, find the intervals increasing, decreasing, relative extrema. We need order pairs for that. Points of inflection provide order pairs, and intervals concave up, concave down. So we have a curve sketching problem here. You want to be able to list out all the properties of the slope and concavity behavior of the graph. And we're going to create a sign line for all the critical points, and then we're going to sketch the graph. All right, so first we're going to find out when the graph is increasing, decreasing, relative extrema. So all that is going to come from the sign line for slope. So we're going to get to that by finding f prime first, find the derivative first. So the derivative, go through appropriate rules here. So x becomes 1, and the derivative for 2 cosine of x becomes negative 2 sine of x. So the two negatives will cancel out, giving us a positive 1 plus 2 sine of x. So we set the derivative equal to 0, and 1 plus 2 sine of x equal to 0. And to find the critical points there, we set sine x equals negative 1/2. And the two x values where sine is equal to negative 1/2 is at negative pi over 6 and negative 5 pi over 6, because we have to look at where we're going to. We're going from negative pi to positive pi. So we have to make sure we fall in that interval there. All right, so sine is negative 1/2 in those intervals, in the third and fourth quadrant. So we work backwards from negative pi over 6 and negative 5 pi over 6. So we put those critical points and the endpoints on the sign line, and then we test values on the interval. So between negative pi and negative 5 pi over 6, we know that the graph is going to be, the slope is going to be increasing during that interval. So we know it's going to be a positive slope. Between negative 5 pi over 6 and negative pi over 6, if we choose negative pi over 4, for instance, we're going to get a negative value in the derivative, so we know it's a negative slope. And then from negative pi over 6 to pi, we can plug in 0, for instance, and we'll get a positive value. So the graph is going to be increasing, hits a relative max, decrease, hits a relative min, increase again. All right, so we can fill out the because statements here by looking at our sign line. So interval increasing, we have two intervals here, so negative pi to negative 5 pi over 6, union negative pi over 6 to pi. And increasing because f prime is positive, greater than 0. Okay, interval decreasing from negative 5 pi over 6 to negative pi over 6 because f prime is negative, less than 0. And then relative max at negative 5 pi over 6 because f prime changes from positive to negative. Relative min at negative pi over 6 because f prime changes from negative to positive. And we can find order pairs by plugging these x values back into the original function. So if we plug back into the original function, we're going to get negative 5 pi over 6 plus root 3 as the relative max, and the y value for relative min is negative pi over 6 minus root 3. And justification, f prime changes from positive to negative for relative max, for relative min because f prime changes from negative to positive. All right, concavity. To determine concave up, concave down, we're going to find critical points from the second derivative and put them on the sign line, and then test each interval with the second derivative. So here is our y prime. To get to our second derivative, we can find the derivative for each term. So 1 is a constant, goes to 0. 2 sine of x becomes 2 cosine of x. So we have our second derivative. We set that equal to 0. When is cosine equal to 0? Once we divide by 2. Cosine is equal to 0 at negative pi over 2 and pi over 2, because we have to, again, fall in a line with the boundaries that's given to us, the bounds that's given to us. So negative pi over 2 and pi over 2. We put them on a sign line as well as the endpoints. And here, between negative pi over 2 and negative pi, we can choose, for instance, negative 5 pi over 6, for instance. And if that's the case, if we plug that in, we're going to get a negative value, all right, negative 5 power 6 plus root 3. We know that's going to be a negative value. It's roughly about negative 1. If we plug in negative pi over 6, okay, we can test the values here. Let's say we can plug in 0. Sorry, if I plug in 0 in for cosine of x, I'll get 2 times cosine of 0, which is 2 times 1, which is positive. And then here, between pi over 2 and pi, we can choose 5 pi over 6 again. And in this case, we're going to get a negative value because cosine in the second quadrant will be negative. So we have in this interval concave down, concave up, and concave down. All right, from there, we also know that there are points of inflection at these critical points since there's a change in signs on either side of these critical points. So from negative to positive, we know there's a POI here. There's another point of inflection at pi over 2 because there's a change in sign on either side of that critical point. So interval concave up, we just read the sign line here. So negative pi to negative pi over 2, union pi over 2 to pi, because I'm sorry, that's concave down. So these two intervals are concave down because f double prime is negative, and then concave up from negative pi over 2 to pi over 2 because f double prime is positive. So points of inflection, these are the x values, negative pi over 2 and pi over 2. And if we want to find out the y values, we can plug negative pi over 2 into each of the original functions. So they have to get plugged in, not into the second derivative. They get plugged into the original if you want to find out the physical location, physical y value on the graph. So we plug negative pi over 2 minus 2 cosine pi over 2. Second term cancels out, so it'll just be negative pi over 2. If we plug in pi over 2, we'll get pi over 2 as a y value. So points of inflections, here are the order pairs. Justification, f double prime changes signs. All right, so now based off of these two sign lines, we can put them all onto one big sign line and then match the behaviors of slope and concavity. And then I also went ahead and found the endpoints as well, so we can kind of know where the graph ends, starts and ends. So if we plug the endpoints negative pi into the original equation, it comes out roughly about negative 1 and change. And if I plug in pi into the original function, I'll get 5 and change. And then based off of all these order pairs from relative max, relative min, concave points of inflection, and endpoints, we can just plot those points on the graph, and then we can just connect the points using the appropriate curvature and slope. So between, so we know the graph is going to start increasing, but maintain concave down until it hits point of inflection at negative pi over 2. Then it's going to change from concave down to concave up. Hits a relative min at negative pi over 6. Continue through to pi over 2. Maintaining concave up all the way to that point, and then from there keep increasing but changing to concave down.